In this set of videos, I am going to try to explain how to use deep learning models, how to use deep learning algorithms to solve practical problems. I will be starting with some very general idea of how the whole thing works, that hopefully everyone can understand, and then I will be going into much more detail into how to actually code the thing, and that will be aimed at the students that are doing our specialization courses and that already know how to code and have the necessary Python knowledge. If you don't and are interested, please do have a look at those courses, because I think it might be the start of a journey that leads you to actually being able to coding these things and opening a whole new set of abilities in your science career. So let's start with that. First of all, we have already mentioned that in general we will see deep learning networks as this big blob made out of different layers, and there are different parts in every layer, which I will not get into yet. But we see deep learning networks as essentially functions that help us solve one problem. For us, it will be important that the problem is something applied, something that's interesting for some research purposes. And most of the times, we are recently working with processing drone acquired images over forest. And that's why here in this example, I have pasted here an image of a sick tree from Zhao Mountain. As you can see, this small image shows a tree taken from the drone, and the tree is sick. There is some deformation here in the middle branches because of an insect called bark beetle infestation that happens there and that we are researching. The people from the Faculty of Agriculture are researching, and we are trying to help them with the data science part. And as you will see, I have superimposed a fine grid here, and this is to show that any type of data, tree image data for example here, can be seen as a matrix. For all of my deep learning networks, the input will be some matrix of data representing something. In this case, every position of the matrix contains an RGB, red, green, and blue value, and because of that, that can be seen as an image. But if I had words, if I have language data, I could transform those into another matrix. It would not be so easy to visualize, but that can be done. And maybe I have structured data. Maybe I have data that contains the name of a client and their shopping habits, or maybe the data contains the identifier of a store from my company and how many people work there and what day it opens, and all of these different types of data can be translated and are translated to matrices. That represents, my data represents the input of my deep learning model. I want to do something with this data. I want to get an output. I want to use this function to model my problem, to solve my problem. For example, in the case of these images taken from the drone of trees, I want to know if they are either sick, like this one. So I want to assign them a category. I want to classify them into one of the possible categories. And this one would be classified into the category of a sick tree. In this problem particularly, there are two more classes. The tree could either be sick or healthy, or it could be dead. We have these three classes. And what we want to do is create a function expressed as a huge deep learning network that receives one image, processes it, passes this matrix through the whole network, and outputs the correct category, in this case, the sick tree. Okay? So I have a deep learning model that can be seen as a function with many parameters. And when I have a function with many parameters, it can be very flexible. And it is said, there is a theorem that states that deep learning networks have the universal approximation property. So theoretically, they can be used to solve any problem. Okay, that sounds very impressive. Maybe it mostly means that they are very flexible and they can have many variables and they can be adapted to solve different problems. That doesn't mean that it's easy or that if I try to solve any particular problem, they will work particularly well. They do work quite well, and that's why we are using them, but this does not mean by a long stretch that they can easily be used to solve anything. Okay, but they are getting pretty decent results in different things, and they have this great flexibility. In order to get my network to output the correct answer given an input, I need to set the variables of my model. This will be a function with many variables, a model with many variables, a model with many parameters is another way of saying it, and I will need to set them, give them correct values in order to achieve the correct answer. Okay, and that process, the process of adjusting the variables, the parameters of the model to get the correct answers, is called training. We also say that the model learns the correct parameters. And it's very important that the training is done using examples. The model learns the correct parameters from examples. Okay, going back to the previous slide, I get an input and I give the model the image, but also the correct category during this initial training phase or learning phase. And initially the model gives, let's say, random answer, but then it checks whether or not, we check whether or not the answer was correct. If it was correct, we say, okay, so these parameters that I have here, these weights are also called, these values for these variables are okay, because I got it right. If I output something wrong, if I say this tree is healthy, and it's not, because I also have the correct answer, then I'm going to say, oh no, these parameters don't work, let's do something else. And at each step, the model will see lots of examples along with the correct answer, and we'll see how many it got right and got wrong, and propose new directions of change of the parameters of the model. We'll start with a certain value for every parameter and change them and see what changes give me more success, and I iterate over that. See more data, see how good I did. Okay, these parameters worked, so let's continue in this direction. It didn't work, let's change. After I have done this, after I have used all of these examples data along with the correct answers to get to the best parameters for my model, to fit the model, to train the model, to get the model to learn the correct parameters from these examples, from these training data, it is called, a part of my data that's called training data that I will use to fit my model correctly. Then I will take another different part of my data and check how well the model works. So with the second part of the data called testing data, I will just pass it through, not give the model the correct answer, and then I will check whether or not the answer that it's giving now is correct. The difference is that in the training step, I use the answers for every image to change the parameters and to see if I did well or not. In the testing phase, I don't do that anymore. I just run all the testing images through the network and see what answers they give, and then after that has finished and without affecting the parameters of the model, I go and check how many I got right. So I have a measure of how successful my model was with the testing data. I have these two very different processes. In the first one, I used a part of the data called training data to set the parameters of the model. In the second part, I use a different part of data called testing data to see how well I did, and I don't change the model anymore. So we have seen the word model quite a lot, the network, the function that I'm using to solve my problem, that I am setting up, that I'm training. That was another important word. And the last word that I want to introduce is loss. Loss is a metric that computes how well I did, how well I'm doing during training or during testing. I have mentioned many times that I look whether or not the answer was correct for every image, but then I also gather together all the results. How many did I get right? How many did I get wrong? The predictions in my model can be different things, can be, for example, the probabilities to belong to one class or another. They can be many different things. And I will use some function to give me a value of how well I'm doing at each moment. This function that gives me a measure of how far the output of my deep learning network is from the truth, that's called a loss function.